All right, geometry class, we are looking at sections 8.2 and 8.3. This follows our activity that we did on discovering or constructing some properties of parallelograms, and we will briefly go over those properties and then apply those properties in some exercises that I have for you. So let's go ahead and take a look at that. So here's our definition of a parallelogram. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. Well, what I mean by both pairs of opposite sides, these two sides right here are opposite of each other, and then these two sides here are opposite of each other. So these two pairs of opposite sides are always going to be parallel in a parallelogram. So also in a parallelogram, if we have a parallelogram, its opposite sides are congruent. So again, opposite sides here are congruent to each other, and these opposite sides are congruent to each other. And similar to the opposite sides are congruent, we have opposite angles are also congruent. So to show you what opposite angles mean is the angles that are directly across from each other, not lying next to, like these two angles right here. No, these are adjacent angles. These two that I drew in like this are known as opposite angles. So those opposite angles are always congruent in a quadrilateral that is a parallelogram. Okay, now a couple other properties we have is if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. And what I mean by consecutive angles are the ones that lie next to each other, so adjacent angles in this case. This right here, P and Q, are going to be consecutive angles. And then QR, those are consecutive. And then RS, those are consecutive. And then SP. So I just listed out all the pairs of consecutive angles that we have in a parallelogram. And all of these consecutive pairs of angles are supplementary, meaning they add up to 180 degrees. So looking at this diagram I have here, I would say that x degrees plus y degrees is equal to 180 degrees. Okay, so that's what it means by consecutive angles are supplementary. Now also, if a quadrilateral is a parallelogram, then its diagonals bisect each other. And what is meant by that is, okay, we're going to draw in our diagonals, these two blue lines here, and where they intersect is where it cuts that diagonal in half. So this segment here, QM, and this segment here, MS, are congruent. And same goes for this diagonal. PM and MR are congruent to each other. So that's what I mean by diagonals bisect each other. So now let's take those properties that we looked at and apply them in our examples that we have here. Our first example, it says find the values of each variable of the parallelograms below. So we have a few parallelograms to look at. And in this first one, we can find x because we know that opposite sides are congruent. So these two sides are congruent. And if we say 4x minus 1 is equal to 15, we have a little equation that we can solve for x and find our value that we're looking for. Okay, so let's do that. 4x, I'm going to add 1 to both sides to get 16. Divide both sides by 4, and we get 4. So there's our x value. Now, to find what y is equal to, we're going to apply that second property that we looked at, that opposite angles are congruent to each other. So this one's pretty simple. We're just going to say, well, y is equal to 53 because y degrees is equal to 53 degrees. All right. Now let's do the same thing over here on this parallelogram. So if it's stated for a fact that we know that this shape is a parallelogram, we should automatically know these properties about them so we can find our variables that we are asked to find. In this one, 2a plus 1, this side is equal to 21. So write that out. And please, on quizzes or tests, don't try to skip steps. Write this stuff out, okay? It helps to see your work and know what, just to know what you know on paper, okay? All right, so solving this for a, we're going to subtract 1 from both sides, get 20. Divide both sides by 2 to get a by itself. A is equal to 10. Now on this one here, we are going to take a look at it, and we can see that these two opposite sides are also congruent, meaning we can set up this equation. 2b minus 3 is equal to 7. And if we solve that, we will get 2b is equal to, add 3 to both sides, you're going to get 10. And then divide both sides by 2, we get b is equal to 5. So there we go. Found some more variables. All right, let's look at yet another example just to give you a good foundation on what we're doing in these sections here. All right, so again, we're going to use some properties and find these values of our variables. This one, this side is congruent to this one, and this side is congruent to this one, meaning we can say, to find x, we can set 2x equal to 10 and solve for that. Let's go ahead and do this one. We can set y plus 2 equal to 16 and solve for y. So on this one, we just need to divide both sides by 2 and we get 5. And then on this one, we need to subtract 2 from both sides and we get y is equal to 14. Okay. And now on this problem here, there's a couple more steps to this one whenever we do our algebra, but it's all the same. Remember, the opposite angles on a parallelogram are congruent to each other. So we can set up 4p plus 3 is equal to 135. Now, when we do this problem, there's a couple ways we can go about it. We can distribute the 4 across, or we can start out with by dividing both sides by 4. And what that will get us on this side, our 4's cancel out, and we get p plus 3 equals 33.75. And now we just need to subtract 3 from both sides, and we get p is equal to 30.75. And that is our value for p. Now we're going to take a look at the properties that we just went over and just state them in a different way. So whenever we state them in this way, what we're doing is we're taking the converse of all of the theorems and properties that we just looked at. So before, what it said was uh, if a quadrilateral is a parallelogram, then both pairs of opposite sides are parallel. Okay? In this one, using the definition and changing it around, it says in a quadrilateral, if both pairs of opposite sides are parallel, then the quadrilateral is a parallelogram. So we are stating pretty much the same thing, but actually these are what proves the shapes that we are looking at are parallelograms rather than another type of quadrilateral. Okay, so here's the definition stated in this way. Let's look at the others. So again, in a quadrilateral, if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. So if we can show that our opposite sides are congruent, then we should know that we have a parallelogram. And in this one, in a quadrilateral, if both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. Okay, let's look at the next few. Here's another one. In a quadrilateral, if one pair of opposite sides are congruent and parallel, then the quadrilateral is a parallelogram. This is a new one. So what this one is stating is if we know this side is congruent to this one and it's also parallel to each other, then we should know that we have a parallelogram. And this here is a converse of what we looked at already. This states in a quadrilateral, if the diagonals bisect each other, then the quadrilateral is a parallelogram. So our diagonals, those are drawn in. Let's do a better job on that one. Okay, what we have is we should know that these two segments are congruent and these two segments are congruent, meaning where they intersect is the point where it bisects the two diagonals. And therefore, we have a parallelogram. So let's take a look at the types of exercises you will see in in using these theorems rather than the previous ones. So what your questions will ask and whenever you are using the converses versus the regular theorems, it will ask you which theorem can be used to show that the quadrilateral is a parallelogram. So we could use our theorems in that way to prove the type of quadrilateral that we have. So in this one right here, in our book, if we go and look at each one of these theorems, they have a name. They're named either theorem 8.8, 8.7, 8.10, something like that. And those are the theorems we're going to use and the names we're going to use to match back and prove that these are indeed parallelograms. So what we see here is our diagonals right here are bisected by each other. So this theorem is the last one we stated. And that one in our book is called Theorem 8.10. So right here, the only thing you have to do is write in theorem, I'm going to abbreviate it, 8.10. And we're done. And on this one, we are being shown that these two sides are congruent. And we can determine, well, since this is 26 and this one's 26, these two sides are congruent. So The theorem that goes along with that one, that the two pairs of opposite sides are congruent, that is theorem 8.7. And you will be given the theorems. If I ask you questions in this manner right here, you will be given the theorems to match back to what you are needing for on a test or a quiz. Okay, so let's look at a couple more. We have two pairs of congruent angles that are opposite of each other. So this one's 71 and that one's 71. Those are congruent, and so are these. So both pairs of opposite sides are congruent. That is theorem 8.8. And this last one is kind of our new one. We did not have a theorem that this was not a converse of one of the previous theorems that we looked at. But this one matches back to a pair of opposite sides are congruent and parallel. That is theorem 8.9. So we will take a look at those in our book. I will make you a chart of them for a quiz or a test for the near future. And you will use these just like we did in these exercises and match what is going on in your diagram and then match it back to what theorem it is being shown that these are indeed parallelograms, rather another type of quadrilateral. Okay, let's go on. And it would seem that we are actually done. This is our lesson quiz, just like always. Complete this quiz as best as you can, and we will go over any questions that you have about it in class the next day. So I will see you all later. Goodbye, everybody.